Hi everyone, my name is Dilyara. I'm a researcher at DeepPavlov, and today I'm going to tell you how to integrate a new component in multi-skill AI assistant using open source platform Dream. So our platform is available on GitHub. We have a website, and you can also try our demo English version on our website. Our workshop today is dedicated to creating an integration into the pipeline, a new component for the conversation. To choose a component, I decided that we still do not have a simple yet effective generative model in our pipeline. So we'll have another generation model, but it's knowledge grounded generation. So I decided that it's a good opportunity to add one more conversational generative model that will provide simple yet coherent responses. So I decided let's try Dialogue GPT model. I prepared a bit of the code here today. We have a development branch for now, and here is the code for Dialogue GPT usage. So you can see here the choice of the generative model name. So if necessary, we could simply just replace it with large or small model or another model that is appropriate for automodel for causal language modeling, and it will work still. So the code is also uses CUDA if necessary, and for the context, it just simply concatenates the different contexts. So what can we do today? Let's start from the dialogue system architecture. So here is the overall architecture of Dream Social Bot that is built using almost all components presented on our open source platform Dream. So we can see here that the pipeline of the user input proceeding is the following. So we get some user input. This is some utterance from the user, and it is annotated using a lot of different annotators that correspond to natural language understanding task. And there are a lot of different sentence segmentation, for example, which recovers punctuation and split sentence utterance to the sentences. There are also a lot of different classification models like sentiment analysis, dialogue act, topics classification, and a lot of different models that are dedicated to knowledge graphs. So like knowledge-based question answering, entity linking, which links extracted, not necessarily named entities to the knowledge base, for example, Wikidata, and some remote APIs, etc. So we annotate the user utterance with different natural language understanding models. And after that, we write down it to the dialogue state, and we also proceed all this information to the skill selector. That is an algorithm which chooses a set of skills that will try to generate responses for the current context. So those skills are called for the generation, and they produce 1, 0, or several hypotheses, which are response candidates, and these candidates are annotated to extract some useful information for the response selection. And after that, those annotated candidates are proceeded to the response selector, which exactly chooses the final response that will be returned to the user as the social bot's response. And also these responses are annotated with the models to provide some particular natural language understanding of the bot's utterance. So Today we are going to add the Dilyara GPT model as a skill to the pipeline. But I want to mention that that this skill will be also available, that this skill can be also used by any other model that wants, for example, to provide some response using this using the context, and therefore I offer you to put this Dilyara GPT model to services, not skills, but use as a skill. So we will put it in services just to simply provide it's like available to all the other models. Anyway, it will be also available if it will be in the skills folder, but I think for just for the beauty of the code, we will put it in the services. So let's start from the beginning. So this is my code in the root of the repo. So as you want here to change the code, I offer you to fork our repository. So you can see here this repository, you can fork it and create your own branch for the development. So let's open the terminal, see, now we are in a dev branch. So let's create a new branch. So we're creating new skill, a new service, new branch, and we want to create a folder. We want to create a new folder in these services with a new, so let's create a new folder. Nope. Let's name it Dilyara GPT. Why not? So what we have here. So what do we actually need? We can see another, for example, another service, Docker file, which will create as a microservice Docker container. We also have requirements, server.py, test.py, and test.sh. So this is the required number of files that we need. So let's consider, let's copy from MaskLM model, because that's no, let's do it like this. Not like this. So this is MaskLM. Just go to services. So let's see here that we have all these files, and let's change them according to our purposes. It's very simple. So let's start from Docker file. What do we have here? That's the check of our pretrend model name or path. So exactly what do we need? Absolutely, it's okay. So we want to use other models. We want to use auto tokenizer, and we also want to use auto model for causal LM. So put it here, and we want to proceed this model using these variables. So let's create it this way. No, I will show you why I'm doing this. You will definitely understand what I'm doing here. So let's, yeah, that's it. So this will give us an opportunity to get this parameter. So absolutely cool. So now we have everything we wanted. So let's remove health check for now. will be able to put it back when you will want it, when you want it. So what do we also have here? I want to put it like this version of the, we also don't need sentence piece. So, okay, what else do we want? We will fix it later when we'll know this information. And we want the main file, server by. And for that, I did this file preparation for our case. So let's copy. It should be in another Flask. Let's check. Let's change it like here. Let's make it here just for this. Cool. It's okay. So let's leave it like this. And what do we want? We want to get our model like this. So this is our model preparation. Let's make it our model. So let's make it like this. And we don't need. So what do we want here? Model tokenizer. So everything is okay. What else do we want? We have decided to remove health checks, so let's remove them for now. What do we else have? Respond bar. And what do we have in here prepared? So this is the generation from, why is this? So let's consider as a response. So cool. Okay. So let's have the that generate response. It gets contexts, a lot of contexts. And what do we see here? Let's make it like this. And what do we have? This for one context. Okay, let's do it for one context. Okay. So now we are returning our response, and we have a function that makes us for us. Like we don't need anything else. Okay, cool. We don't use prints. Well, it should be works definitely. So okay, and we have a function. Now we want to have contexts. Let's consider it like this. So each context is a list of utterances, and we want them to be so what will be the result? Result, make it here. Result is a list of responses where each response is we get some contexts and we need to result is a list. Result is generate response for the context. Good. So that's what we have. So here, and this is the resulting utterances, but still we have responses. Now let's make it as a skill. While still this is not a skill, this is just a generate. So let's return also confidences. Confidences is a list, and confidences gets Let's assign 0.9 just for now. I will explain it later, and actually let's place it. Let's place it here as a default. So put it here. Okay, let's make it here, and the result is a list of empty utterances of line of contexts, and the confidences. This is a list of 0 points like this. So we do have here these responses, and let's understand what should we return as a skill. What does any skill returns? Let's check this one. I like it. I did it by myself, so we just sonify this information. But actually, we do not need to return any of these things. So you can see here we have responses, confidences, and we do not need these. So that's cool. Okay. Actually, that's it for the code of this model. That definitely should work. Oh, let me replace this information. Cool. So now it definitely should work, but still we do have to fix some problems. Okay, test price not yet changed, but we still can understand what we can do this. So let's consider we need to add this new skill, new service to the skills. So let's add it to the dream. And first, what do we need? As you remember here, we are getting contexts. So we need to create this context. Okay. So let's start from here and understand where should we add it. Just simply here, this is the skills, lots of different skills. Let's copy only any of them. I like this one. Let's get to the end of the list of the skill. Let's check it. Before template skill, I will add it because the template is like the last one for us. Now we just decided to make it like this, and let's call it Dial GPT. Just Dial GPT skill maybe, but okay, Dial GPT. So we are calling it Dial GPT. We need to assign any skill. Let's find notes. It's empty, so 8125 response. The skill with attributes and the what is this information? Let me discuss. So this is the name of the skill in a pipeline. So skills are denoted and can be saved to the dialog state using this name that you will give it. So the connector determines how to connect with this microservice that you have. So for example, you have here the path to the Docker container as a microservice that will be raised separately, and the agent container will send the request to this address. So what we see here, the dial formatter is an input formatter. So this is a function that pre-process dialog state to be sent it to the to this microservice. As you remember here, we are accepting the context, where the context contains a list of where each context is a list of utterances of the dialogue. So we don't need to send a lot of the utterances. Let's consider, for example, 3 or 5 last utterances. And what else we can see here? The response formatter. This is the formatter for the outputs. For the skills, I suggest you to use the same formatter as I do. This formatter is universal for three variants of the results. So it can be only responses and confidences, and also it can be responses, confidences, and attributes, and also it can be responses, confidences, attributes, human attributes, and social bot attributes. So feel free to use it as you wish. So everything is fine. So we need to replace this formatter. Let's find formatters. Where are they stored? They are stored in the state formatters, DP formatters. Let's find something with the context. So let's try if we have it. It's not exactly that we wanted. No, it's like for run. Context, we have context, Let me just, oh, I like this one. Now it has hypothesis. Do we have a history maybe? I just don't want to create a new one that will be the same as, no, it's just like human utterances, last utterance and history, utterances, histories. Yes, that's what we need. So this is last utterance and history dialogue. So we get last and utterances because we don't want to send all of them. It will be too long when a lot of utterances in the dialogue. So what else do we have? We have the last sentence, the last utterances, and we also have utterances histories, which are all of the utterances texts. So that's fine for us, I think. So we will have several last utterances. So let me choose this one. I'm replacing it. Okay, now what we should remember, we have not the utterance, not these, we have utterances histories. Okay, anyway, let's create it as utterances histories, and what we should take into account, the number of last utterances we consider. So there is some function that have default number was like 5 utterances, but we don't want to have 5 last turns. It will be 10 utterances. We want to have 3 utterances, not 3 turns. Turn is a pair of bot and human utterances. So let's just simply cut it. Yeah, why not? So we can see here the context is the list of the utterances. So let's consider we have minus max history depth. Let's do it here, like 3. Yeah, like 3. Okay, it will be enough. 3 last utterances. So cool. What else do we have? We have our formatter. So it's cool. So what should we do right now? We should open here and create. We want to create a service for it. Let's copy any of them. It doesn't matter actually if you understand what is given in here. Dial GPT. 25. We decided service name. We can pass it, but I think we don't use it. But anyway, the folder is services. Dial GPT. We didn't do anything wrong, I think. Yes, it's okay. So the port is 25. I think it will need just for now, let's consider it as 2 gigabytes. It's not, actually these limits are used only when you're raising these containers using Kubernetes. They are something like artifacts from our participation in Alexa Prize Challenge. So let's let it like this for now. So let me check. So, oh, don't forget that we had pre-trained model name or path, and we wanted to use this variable, as you remember. So let's add it as an argument, and we'll set here. Let's do not do the default value. I decided, so let me find which one I did use it here. Here, oh, that is it. So let's use it. Where? Here. Yes, here. Cool. Actually, I can use it without. Okay. So we've just did it almost finished. Let me finish just this information. Dev YAML is about mapping of folders and mapping of ports. This is very convenient for debugging. Don't worry if you don't know how to do this. Just simply copy this one that you already have, replace it with your GPT model. So the mapping of ports doesn't matter. Don't worry. So services GPT. So we're just mapping to update all these files to be updated in the Docker container when it is restarted. That's it. What does it mean, actually? So saving, that's fine. What else do we have? We want to set an queue the visible devices. Why? Because we want to use it. Yes, definitely. Let's put it here. Oh, we already have environment. Okay, we're putting the zeros value of the variable. And by the way, I want to raise all of the containers as a proxy and only my container locally. My and agent and Mongo, of course. So I want to also set a special device that I have. Let's check which one do we have available here. Let me just check it. So let's choose the second one. Okay, so the second one doesn't matter. Let's just copy it. And set another device using, for example, Docker Compose, but we decided for the beauty of the code, all the devices are set to 0 and the mapping to the correct GPUs is done in other YAML files. So let's consider this one. So I think we have already finished all these things. Let's try to build and up this particular service. Let's start from it separately, and then we'll raise all other. So let me just show you the README file. This is absolutely amazing README that you can check. And let's find here Dream locally. So we have used this file is containing also information about agent and Mongo. It will be always raised locally, just for your information. And we also have this Docker Compose override YAML. That is this one. We have put it here. It's okay. So, and we also have dev YAML with our mappings. We have put it here. So to build our concrete, so we also want sorry, no, I think, yeah, I need this one just because we have test YAML that we want to use. That's okay. Test YAML up minus build. We want to build and raise our container that is named as Dilyara GPT. So everything's fine. Let's start. I will just show a bit more. Okay. Let's wait for some time because it needs to download and oh, cool. Okay, we are waiting for the logs that we have passed in the server. So we can find it here. So the model is ready. Yeah, it is. So Dilyara GPT model is ready. How can we check it? Let's finally go to the test file that we wanted to create. It's time. So this is the previous one from the previous model. Let's remove everything that is not for us. Exactly. So we have some. Oh, can I go there and get these contexts? Let's create here some contexts. So these are contexts for the dialog, and we can name them as transfer histories. Yes, exactly. So why should we do this? Like, no extra variables. So gold result, we still don't know what will be the gold result. Let's first of all print the result and see what will be our gold results. It will be correct to do this. I need one more terminal because this one contains raised. So now let's go to the services and Dilyara GPT that we have. So let's try to run our tests. I'm good. How are you? And like the new one. Perfect. Yes, that is that I wanted. Absolutely. Object it from another source. So this is the result. So exactly. Don't print it. Just simply assert. It works for a long time. I think it should be a bit accelerated further. Story. So it works for now. We know like exception. So it works. It also works. It's okay. Oh, and now we want to get it as a proxy. So we want to run all the components as proxy except of our new one. So that's why I didn't edit our new component to proxy YAML. So proxy YAML file contains this mapping of all of the container except of the agent and Mongo containers to those that are connected to our special server that hosts these microservices. So when you use proxy YAML container, you just simply raise all these containers, but instead of the original consistent, instead of the original containers, you are raising these containers that are actually just small, really small proxy containers to the to our services. So let's try. So if we didn't put here agent, Mongo, and our Dilyara GPT, so all the containers will be raised as proxies, and only my container will be erased as local, and of course agent and Mongo. By the way, let me add it to the connector. By here, the skill selector, we need to add our model to sensitive case. No, will not respond when the sensitive scale case. So let's see. A lot of different skills. Let's add it here. I think this is a general case. We do not have some special requests. We do not have some particular intents to be address, and we do not have a sensitive topic or requests. We are just integrating here this. So let's try it. Okay. But take into account that I wanted to use this test here email, so let's just simply nope, another one, just not this one. So let's stop it. We stopped our service, and now we want to raise using this information for our service, and we also need to add this proxy email. So let's choose this. We want to build all of the containers, and we want to add not this, but exactly this. So cool. So as you can see here, agent and Mongo, Docker Compose override, dev YAML, test YAML, and proxy YAML. Perfect. Let's do it. We'll have some time to wait because although those components are small, they still need to wait until they will be raised. So cool, look here, everything's fine. So the application can now start. This is a magic response from Docker Compose agent container. So let's find the let's chat comment, and I want another. So in this terminal we have raised all these models, and here we have to raise how to have to talk to it. Let's check. Yeah, it's okay. So here it is. Dialog GPT produced us a dot. That's strange, but still, let's check it. How are yours? We have to send it to punctuation model, so it doesn't matter how do I write without punctuation or not. Yes, see here, this is the logs from our service. Dialog GPT produces the response. I'm good, how are you? That's amazing. It wasn't chosen by the response selector because this is the beginning of the conversation, but still it is here. So anything extraordinary happened today. Yes, I went to the theater. Let's make it like this. Maybe it will give us something interesting as a response. Let's try to find the response from the. I'm glad you enjoyed it. Oh, thank you very much. So it works. It works, and we have done it. Thank you very much for joining us. Goodbye.